Welcome everyone to Dream Academia. Today will be the third lecture of differential calculus, and today we will be mainly discussing about graphs. But before doing graphs, you should know what is a function, because we will be doing graphs of different functions. Okay, so first you should know what a function is. So let's start. Um, Now today I have written everything for you, because if I write while teaching, then it takes a lot of time, and like in that way our syllabus won't be completed. Okay, so today I have written everything. I will be just explaining you the things. Now see, first, what is a function? What is the definition of the function? Okay, and how a function is different from a normal relation. So see, let x and y are two non-empty sets if a relation, okay, if a relation, a normal relation you are defining on the set x and y, f associates each element of set x to a unique, okay, see, unique term is very important, unique element of y, then f is called a function from x to y. Now, every relation is not a function. Only those relations which associates each element of the set X. Each element. This term is also important. Each element. See over here. Suppose this is my set X. Okay. And this is my set Y. Now, all the elements x1, x2 and x3 are associated by the function f. So, this first condition is satisfied. Each element is associated. Now, each element is associated to a unique element. See, x1 is associated to y1, x2 is associated to y3, and x3 is associated to y4. So, each of the element is associated to a unique element in the set y. So, this relation f is a relation from x to y. Now, since these two conditions are satisfied, so I will call this relation as a function. So what are the two conditions? First one is all the elements of x should be associated, and number two, to a unique element in y. Thus, this relation is a function. Okay. Now, this is a statement, an important statement, which can come sometimes directly in your exam in the assertion reason questions. So, what it is saying that all relations are not functions, but all functions are relations. Obviously, this is a relation from set x to y, and this is a function as well, or a mapping. A function is also called a mapping. Okay, mapping or function, anything. So this is a function, but all relations are not functions, because you can see, I will show you one example over here. Yeah, let me choose the pen. See, so if I have a, suppose I have a set x and a set y. Okay, now suppose my elements, let it be like this: x1, x2, x3, x4. Four elements. and here I will take y1, y2, y3, y4, y5, 5. Now suppose I take one relation, something, a relation R from set x to y, which will associate, for example, you think that y1, x1 is associated to y2, x2 is also associated to y2, x3 is associated to y4, x4 is associated to y5, and suppose x2 is also associated to y3. Now, this is not a function. This is not a function. Why this is not a function? Because you can see that this element x2 is having a relation with two elements in y, that is y2 and y3. This cannot happen in a function. Each of these elements should have a unique relation. It should be associated to a unique element in set y. So this relation is not a function. Again, suppose I take one more example. X, y. Okay. Should I? Okay, I will just take numbers this time. 1, 2, 3, 4, and suppose 5, 6, 7. Now, if I take the function, not the function, a relation. Okay, if I take the relation like this, 1 is associated to 5, and 2 is associated to 5, for example, and 3 is associated to 7. Okay. Now this is also not a function. Why? Because each of the elements of x is not associated. You can clearly see that 4 is not associated to anyone in y. So this is also not a function. Not a function. Okay. Fine. So I think now you can, if I give you any random relation, then you can say that it is a function or not. Okay. From here you can say that. Now see. So now, as you have learned in relations, the different domain and range and codomain, all these terms, over here also you can see that. So similarly, for a function we will define what is a domain. A domain would be the entire set X. Okay. The entire set Y will be your codomain, not range. Range will only have those elements which have a associating member in X. You can see that all the members, all the values of Y does not have a member which is associated to it. Okay, Y2 does not have anything. So Y2 is not in the set of range. So Y2 will be excluded from the range. So your range is always not equals to codomain. Very important point. Okay. So if you have to, in the question, if it is given write the codomain, then you have to write the entire set Y. And if it is asked to write the range, then you have to write the range. Only the elements which you are getting, which has something associated to it. Okay. So this is the form of writing y1 equals to f of x1, y3 equals to f of x2, y4 equals to f of x3. Okay. So Next is image and pre-image. So basically the all the elements in the set Y is called the image of X under F. Okay, the elements in the set Y which will be having X associated to it, that is the range set, the set of range, okay, would be your image, and X is called the pre-image of Y under F. This is just a term ऐसे ही याद रखने के लिए, because sometimes mathematical terms are also used in the question, so you can understand that. Okay, so this is also again a statement that a range can be defined as the set of image under F. Okay, now we will come across two types of functions, that is real function and real valued function. So understand the difference. So real function is a function which has both domain and range as set of real numbers. That is, both the domain and range will belong to R. R is the set of real numbers. Okay, that is a real function. And a real valued function will have only the range as set of real numbers. It is not necessary that the domain will also be the set of real numbers. It can be a set of complex number. Okay, now I have given one example over here. You can understand how a function basically works. Suppose I take this thing, this box, this rectangular box, as a machine. Okay, any machine, suppose your AC or your fridge or anything. So this machine is working on a function f, and I will give x as input and I will get y as the output. Now if I give, in case of a real function, if I give input as a real number, this machine will work with the function f and it will give out a real value. But if my function is designed in such a way that I give here some complex values, but my domain, my range will always be real numbers, then my function would be called real valued, because the value is coming out to be a real number. Okay, it's easy now. You can understand what is a real function and a real valued function, and in entire calculus we will be dealing only with real valued functions. Always a range will be a real number. Okay, fine. Now next. Okay, now this is a question. See the question. If f of x equals to cos of log x such that y greater than 0, then show that the arithmetic mean of f of xy and f of x by y equals to f of x into f of y such that xy greater than 0. So AM is arithmetic mean. Very easy question. You have to just find out the arithmetic mean of f of xy and f of x by y. You will get a function in log xy and log x by y. This is the main thing. You just have to break this log xy into log x plus log y, because log AB is equals to log A plus log B. Okay, and similarly log A by B is log A minus log B. Break it and apply trigonometric transformation, which is very easy. Cos x plus y plus cos x minus y is 2 cos x cos y. Okay, you have put it and you get it to be f of x into f of y. Very easy proof. This is very easy. This is proved. Now here, if you have noticed one thing, that it is given in the question that xy is greater than 0. Why? Because again I have said we will be working only with real valued function. Real valued function, if in the graph of log x, actually if we put this as negative, then your log will not work. Okay, so your output won't be a real number. but we need output to be a real number. That's why your x would be always positive, so that my output comes out to be a real value, a real number. Okay. Now we will do. Acha, before graphs, we have to do one more thing. We will be doing graphs of functions. Okay. So you should know what is a function, and you have seen it from your definition, but every time you will not, you will not find a lot of points, and you will check whether this is related to that or not. You will see the graph and just say that whether the graph given to you is a function or not. Okay. Now how to see that we will be done. How to determine a function from graph. Okay. So how we will do this? See, what is the basic definition of a function? Everything will come from the basic definition. A basic definition with अब देखो, अब we will go back to that again. देखो क्या है कि the function will associate each element of set x to a unique element in set y. Also, I have given you one example over here to explain that one single x cannot have two values of y. It should be a unique element. So, ऐसा intuition आना चाहिए आपको कि suppose I have a graph like this. Suppose I have the graph of x square plus y square equals to r square, which is the graph of a circle. This is r. This is not a function. Why this is not a function? Because you see, if I draw lines parallel to the y-axis, x, 1. Okay, if I draw lines parallel to the y-axis like this, or this, what I am seeing that अगर कोई लाइन y-axis के parallel है, इसका मतलब क्या होता है कि that at that point the value of x is constant. Any line parallel to the y-axis means the value of x is constant. Any value of y will give me the same value of x. So the value of x is constant. So for a same value of x, suppose this is x1, I am getting two values of y. y1 and y2. So this is not a function because it is not giving me a unique element in the set y. I am not getting a unique y for a value of x. So this is not a function. So from here you can understand that if I have to check whether a graph is a function or not, okay, if I have to check whether a graph is a function or not, then I have to see by drawing lines parallel to the y-axis. Okay, that is the basic funda. आपको बस ये याद रखना पड़ेगा कि अगर आपको देखना है कि कोई ग्राफ फंक्शन है या नहीं, कोई गिवन वैल्यू, कोई गिवन ग्राफ इज अ फंक्शन और नॉट, just have to see by drawing lines parallel to the y-axis. Okay. अगर मैं सेमी सर्कल ले लूं, though this is not seeming to be a semicircle, this would be y is equals to under root r square minus x square. If I take this, then this would be a function. And if I draw lines parallel to the y-axis, you can see that it is cutting only at one point. So this is a function. Okay. So just draw lines parallel to the y-axis and see that whether your given graph is a function or not. Okay, so now we will be doing some graphs of some common functions. So now we will be doing graphs of some common functions. So you can see from the graph that these graphs are functions, because if you draw a line parallel to the y-axis, it will cut the graph at only one point. Okay, see, the first is a constant function. Okay, constant function. Constant function is a very simple function which is f of x equals to k, any constant, and k is anything. K belongs to R as well, any natural number, any real number. So that would be a line parallel to the x-axis, very easy. And the domain would be any real number, and range would be only k, because whatever value of x you will be putting in your function, whether positive, whether negative, you will get y equals to k. So range is k. Singleton set. Okay. Now next is the graph of a very common graph, f of x equals to kx. So this graph would be a line passing through the x-axis, a line passing through the origin. Sorry, a line passing through the origin, and the angle that this line will make would be theta with the positive direction of x-axis. Now, if I put the value of k as 1, this angle would be 45 degree, and this function would be called identity function. So if you have, in the question, if it is given an identity function, so you have to understand that they are meaning y equals to x. Okay, this is the identity function. And domain is R. If I put real numbers, you can see that the range is coming out to be all real numbers, both positive and negative values of y. So range is also real numbers. नेक्स्ट इज पावर फंक्शन. ओके, पावर फंक्शन यहाँ से बहुत इंपॉर्टेंट स्टार्ट हो रहा है. सो if I tell about power function, so the general form would be f of x equals to x to the power n. Okay, f of x equals to x to the power n. Now there will be two cases. First would be if n is even. Okay, if n is even and n is a natural number, not a fraction, and n is even, then I can write n in the form of n equals to 2m, and then I will draw the graph. So now in this graph I will be having the points x comma y and minus x comma y as well. If I put x positive and if I put x negative, I will get the same value of y, because this would be an even power. Okay, so this graph would be symmetric about the y-axis. You can see, though it is not very much visible from this diagram, but this graph is actually symmetric about your y-axis. Now, suppose you have to draw the graph of x square and x to the power 4. Okay, x to the power 4 and x to the power 6 I have taken. Okay, x to the power 4 and x to the power 6 in the same graph. So how you will draw? So first you draw a rough diagram of any one, x to the power 4 or x to the power 6, any one you can draw. Then with the help of that graph you have to draw the other one. Okay, so how it would be? So I will divide the domain in two parts, that is from 0 to 1 and 1 to infinity. Now I will draw this for one side only, for the positive direction of x-axis, because it would be symmetric. So whatever would be on the left hand side, it would be again on the right hand side. Okay, so from 0 to 1, x is a fraction. So the value of x to the power 6 would be less than the value of x to the power 4, isn't it? So from 0 to 1, if this is the graph of x to the power 4, then the graph of x to the power 6 would go below it, because it is smaller. Okay, and from values greater than 1, it is normal. Again, like if it is 2, then 2 to the power 6 is greater than 2 to the power 4. So this would be going above the graph of x to the power 4, like this. Okay, fine. Yes. Now the next one. So since you have drawn it for one direction, it is the graph of x to the power 6. If you have drawn this for one direction, it would be same in the left hand side as well, because the graph is exactly symmetry. It will give exact same features on the left side. Okay, so ऐसा हो गया ये same. Okay, so as a homework, I've given you to draw the graph of x to the power 8 and x to the power 2. Draw this graph in the same graph, and no need to do it in a graph paper, just do it in simple plain white sheet. Okay, as a practice question. Now, case 2. Case 2 would be if n is odd. If n is odd, you can understand very clearly that if I put negative values of x, then my y won't be positive because n is odd. So at that time, y would also be negative because negative power of minus is negative. So this graph would be symmetric about the origin. See, it is symmetric about the origin. Okay. So over here also we will plot two graphs. We will do x to the power 3 and x to the power 5. Okay. Now suppose I have drawn x to the power 3 as my base graph. Then again we will be dividing this graph into two values. Now this graph won't be same on both sides because this is a odd function. We will learn what is an odd function, even function. So it is an odd function. This won't be same. So first you see the value of x between 0 to 1. Sorry, 0 to 1. Okay, so from 0 to 1, x's cube would be greater than x to the power 5. Okay, so x to the power 5 would be below x's cube. Okay, and for values greater than 1, the graph of x to the power 5 will be above x to the power 3. Okay, done. Now, in the negative side, you see, from minus 1 to 0, if I put x as minus half, then you can see x's cube equals to minus 1 by 8 and x to the power 5 is minus 1 by 32. But in this case, x's cube is greater than x to the power 5 because these are negative values. Yes or no? So, in this case, the graph of x to the power 5 would go below x's cube, and for values greater than minus 1 it would be same. It would be greater. Okay. So this graph is also done, and two homework question as the graph between x to the power 7 and x to the power 5 in the same graph. Okay, draw the curves in the same graph. Okay, now is negative exponent functions. Okay, this is also very important. I will take the power as a negative one, and again two cases, if n is even and if n is odd. If n is even, then your values again it would be like x comma y is there, so minus x comma y would also be there, because quite obvious, because uh, your function, if you put minus x, then you will get a positive value of y. So this graph would be symmetric about the y-axis. Now drawing the graphs. Now over here you see from 0 to 1, x to the power 4, x to the power minus 4 is greater than x to the power minus 2. Why? Because if I take a fraction, और fraction का भी फिर से inverse हो जाता है, तो x to the power minus 4 would be greater than x to the power minus 2 from 0 to 1. So this graph would be above. And again, from values greater than 1, x to the power minus 2 would be greater than x to the power minus 4, so minus 4 would be going down. And similarly, it will be same from the left hand side as well, because this graph is symmetric. Okay. Yeah. So this would be the graph of x to the power minus 2, and this is the graph of x to the power minus 4. Okay. And draw these two curves, x to the power minus 4 and x to the power minus 6, in your homework. The same graph. Okay. And one more thing, this n would be a natural number, no fraction. Fraction अगर ले लेंगे तो वो कुछ और function होगा और different type के graphs होगा, वो हम लोग next lecture पे करेंगे, ठीक है? Now today we will be dealing only with natural numbers. When n is a natural number. So again, now if n is odd, we will see. So if it is a odd function, if n is odd, then you know that the graph would be symmetric about the origin. So over here you see, for values between 0 to 1, x to the power minus 5 is greater than x to the power minus 3. So it will go up, and then after 1 it would go below. Okay. Over here, for values between, this is minus 1, this is 1. For values between minus 1 to 0, x to the power minus 5 would go below, because negative values would be coming. And for values, for as soon as it will cross minus 1, it would go above. Okay. Now the last function would be exponential for today. Okay, last function for today. Don't be so happy by listening the last function. Last function for today would be e to the power x, that is the exponential function. Now e has a positive value of 2.41. It is a irrational number and it has a positive value. So anything, any power of x which is greater than 0, okay, would give me values which are definitely more than 1, because 2 to the power 1, 2 to the power 2, all such values, assume it to be 2, so it would be not 1, to be more than 1, okay? The graph would go like this, greater than 1. And for values of x negative, if x is less than 0, then it will be 2 to the power minus 1, 2 to the power minus 2, like this, which will be a fraction less than 1. So this the part of the graph would go like this, and this would never touch the x-axis, never. It would go like this for infinity. Okay. And you know, at x equals to 0, it will be 1, because e to the power 0 or anything to the power 0 is 1. Cool. Now for e to the power minus x, it will be just the opposite. You can also understand it like this, that if x is negative, then the value should be positive. So it will be greater than 1. And if x is positive, then the values would be negative. Sorry, if x is positive, the values would be fraction and it would be less than 1. So it would go like this. And at x equals to 0, it is again minus 1. X equals to 0, it is 1. Okay, fine. So yeah, this was all about today's lecture, and there are many more graphs. We will be doing that in the next lecture. Okay. I will give some questions on functions, where you have to identify whether the relation is a function or not, and some questions on these basic graphs, whatever we have done. You should know how to draw a graph from a given curve. If you have given the curve of x square, you should be able to draw a rough diagram of x to the power 8. So all those things, I will be giving you 2 or 3 questions. Practice that, and again we will do in the next lecture. Okay.